Good morning, students. Today's topic is page replacement algorithm. In the previous topic, we will discuss about virtual memory. It is implemented with the help of demand paging. What is demand paging? What is page fault? And for page, when page fault occur, if the frames are not free, what is the victim? Now, here we discuss about how to select that victim. It means when a page is demanded and frames are not free, then we deallocate the frame, free the frame, and replace the new demand pages into the physical memory in frame. For that, we need the page replacement algorithm. So page replacement algorithm is required for the lowest page fault rate. It means that the algorithm which have the lowest page fault is the better one. So when a string is given, a string which means that the pages which are referred is given in the form of string, that is known as the reference strings, and we compute the page fault for that strings in the page replacement algorithm. The example of the reference string is here, this one. This is the reference string 23815314672134661. It means this these pages are required to execute the process. Now first is page 2, then 38153, and so on. The nominal phenomena is that if we increase the number of frames, the page fault will be decreased. This is a normal phenomena, which means that if we increase the space of frames, means from 3 to 4 and 4 to 5, the page fault will be decreased. The first algorithm is the Fifo algorithm, which is known as first in, first out. It's a very simple implementation method, like in data structure in queue, जो पहले आया वो पहले जाएगा. It means जो पेज पहले रेफर हुआ है वो ही आउट होगा. जब वो फुल हो जाएगी फ्रेम्स, तो अगर हमें कोई फ्रेम को फ्री करने की जरूरत पड़ेगी, विक्टिम क्या होगा? जो सबसे पहले आया होगा. तो इसके लिए हमारे पास क्या गिवन होगा? रेफरेंस स्ट्रिंग गिवन होगी और नंबर ऑफ फ्रेम्स गिवन होंगे जो पहले इनिशियली क्या होंगे? एम्प्टी होंगे. देयर इज अ थंब रूल. मतलब क्या है इसमें? फर्स्ट फीफो में थंब रूल क्या है? जो सबसे पुराना पेज है मेमोरी में वो सबसे पहले जाएगा. तो एक थंब रूल है इसके लिए, अगर हमारे पास 3 फ्रेम्स है, जो पेज 3 बार रिपीट हो गया वो ही आउट होगा. अगर 4 फ्रेम हो गए तो 4 बार जो पेज आया वो रिपीट आउट होगा. मतलब विक्टिम कौन सा बनेगा? जितने फ्रेम्स है उतने नंबर ऑफ टाइम वो पेज अगर रेफर हुआ है उसमें मेमोरी में है तो वो ही रिप्लेस होगा. We will see in the next example. So this is the example of FIFO. Consider page reference string is 12321414216221632 and we given है 3 पेज frames. It means हमें क्या given है? 3 frames और ये reference string given है. तो क्या find out करना है? Number of page fault. Firstly, you write the reference string in this format. This which is given 1 2 3 2 1 4 2 1 6 1 4 2 5 6 2 1 6 3 2, and the 3 frames are empty, so we make 3 blocks in the form of frame: first frame, second frame, and third frame. Now initially 3 slots are empty, so when 1 2 3 they are allocated to the empty slot, 3 page faults occur because the frames are empty. So we didn't remove any frame because frames are empty. We allocate the pages to the frames. Like in first frame 1 is required, so 1 is occupied in first frame. 2 page number is allocated to the second frame, and 3 page is allocated to the third frame. It means that initially we have 3 page faults for 3 page reference. Now next page is 2 is referred. It is already in the memory. Here you see that in second frame 2 page number is all there, So this one. So we didn't need any frame to deallocate. So there is no page fault. Next, page 1 is ref1. It's already in the memory in first frame. So there is no page fault. Now, page 4 is refer. It is not in the memory because in the memory 1, 2, 3 pages are there. 4 is not there. So we add free the frame and replace the 4 with the that page. So look at that. Which page is the oldest one? 1. I earlier said that number of frames is 3. So 1 is repeated 3 times. So 1 will be replaced with the 4. So next frame allocation is 4, 2, 3. Here you see that only one frame is replaced changes, which means that 4 is replaced with the 1. 2 and 3 are reside in the memory. So next page is refer 2. 2 is already in the memory, so there is no page fault. Next page is 1. So 1 is not there because 4 to 3 is there. Now 1 will be replaced with the 2 because 2 is the older one. So this is the fifth page fault. Now next page is refer 6. It's not in the memory. So 413 there is no 6. So 6 is replaced with the 3, which is the older one. Now next is the 1. 1 is already in the memory, so no page fault. Next is the 4. 4 is there. Yes, 4 is there, so there is no page fault. Next is 2. 2 number page is referred. It is not in the memory, so it is replaced with the 4 because 4 is the oldest one. So 4 will replace this and new frames are 2, 1, 6. Next page is the 5. So it is not in the memory, so it is replaced with the 1 because 1 is older one, because 1 is repeated it 3 times. 2, 5, 6. It's only for the FIFO. Repetition of pages is only for the FIFO. Now 6. 6 is already in the memory, so there is no page fault. 2. 2 already in the memory, there is no page fault. 1. 1 is not in the memory, so 1 is replaced with the 6 because 6 is the older one. Now 6 page is referred. It is not in the memory. It is replaced with the 2 as 2 is the older one. Next page is 3 is referred. So it is not in the memory and it is replaced with the 5 because 5 is the oldest one. Next page number 2 is referred. It's not again in the memory. So we allocate the frame, free the frame, and it is replaced with the 1. So this is the final. All pages are referred and allocate the memory. So there are 12 page faults which we calculate. A small topic is there, validity anomaly. It's related to the FIFO. Earlier in previous graph, I said that if we increase the number of frames, it will decrease the number of page faults. This is the normal phenomena. But validity states that if we increase the number of frames, it will increase the number of page faults. Means more frames, more page faults. It's particular for some strings. For example, this is a string and 5432, 541, 54321. So with the help of 3 frames, initially frames are empty, 5 is allocated, 4 is allocated, 3 is allocated. 2 is not in the memory, so replace with 5. 5 is not in the memory, replace with 4. 4 is not in the memory, replace with 3. 1 is not in the memory, replace with 2. 5 is there, 4 is there, no page fault, 3. So 3 is replaced with the 5 page number and 2 is replaced with the 4. 1 is already, so no page fault. Total fault is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 page faults there with 3 frame slots. Similar string with 4 frame, it will be decreases, but with the help validity state that if this is the string, the page fault will be increased, that is 10. It means that it is not always if we increase the number of frames, it will decrease the number of page fault. Validity state that if more frames, more page fault. We will see in the graph. This graph shows that if frames are 1, 12 page fault there. If frames are 2, 12 page faults are there. If frames are 3, 9 page fault are there, and if frames are 4, then it will increase 10. This is the Baladi anomaly. Means if we increase the number of frames, it will increase the number of page faults. So this is the Baladi anomaly. Next algorithm is the optimal algorithm. Optimal page replacement algorithm is the best algorithm in the terms of page faults. It gives the minimum page faults. So in this, we replace the page which is not used in future for longer time of period. It means that we see all the reference string in future and replace that page which is not used for the longer period. It means the frames in the pages loaded in the frames we see in the future, these pages which is not used for longer period will replace the page, demand page. So again we take the same example: 123, 214, 216, 142, 562, 163, 2. So initially 3 frames are empty. Similarly, 3 slots are empty. When 1 is referred, 1 page fault, 2 is referred, second page fault, 3 is referred, third page fault. There is no need to free the frame because initially frames are free. So when page 2 is referred, it is already in the memory, so no page fault. Page 1 is referred, it is already in the memory, so no page fault. Now page 4 is referred, it is not in the memory, so we want to free the frames. So look at this. In memory 1, 2, 3 is the page is loaded. Now in future, see, 2 is used, 1 is used, but 3 is used later. So we replace the page number 4 with the 3 because it is not used for the longest duration. So the next is 1, 2 and 4 because 3 is replaced with the 4 because 3 is not used for the longer period in future. Now 2 already in the memory, no page fault. 1 already in the memory, no page fault. 6, it is not in the memory. Now 1, 2, 4. In future after 6 you see that 1 and 4 is used, 2 is used for longer period because 1 and 4 are used earlier and 2 is used later. So 2 will be replaced with the 6. So 164 is the new allocation. 1 already in the memory, so no page fault. 4 already in the memory, so no page fault. 2 already in the memory, so there is no free frames, it replaced with the float 4. 4 is already in the memory, so 2 is replaced with the 4 because 1 6 is used earlier and 4 is not used in future. 5, it is not in the memory, no free frames, so look at 162, 6 is used, 2 is used, 1 is used later, so no page is replaced with the 1. 6, no page fault. Then 2, no page fault, already in the memory. 1, so 1 is not there, 562 is there, so 6 is used, 2 is used, so 5 is not used for longer time period, so it is replaced with 162. Page 6, it is already in the memory, so no page fault. 3, it's not in the memory, so in future 162 only 2 is used, so we replace 6 or 1, कोई भी एक इसमें से हम रिप्लेस कर सकते हैं. We replace with 1, so 362 is there and last one is 2 is referred, already in the memory, so there is no page fault. So total page fault are 9, which is the better than the FIFO. Next one is the least recently used page replacement algorithm. In this algorithm, we choose that page which is used recently, not recently used. It means least recently used. The pages which used recently not replaced with the frames, pages, new pages. It means we free the frame that page which is least recently used. So we see the backward thing. Take the same example 123, 214, 216, 142, 562, 1632. So initially 3 frames are there, they are empty. So 3 page faults occur for 1, for 2 and for 3 because they are empty. So there is no need to replace that page. 2 already in the memory, so no page fault. 1 already in the memory, so no page fault. 4 it is not in the memory, so we replace 1 is used recently, 2 is used recently. So with which frame is not used recently? That is 3. So 4 is replaced with the 3. 2. 4 and 1 are used. 2 is there, so there is no page fault. 1 already in the memory, so there is no page fault. 6 not in the memory. 1 and 2 are recently used, so we replace 4 because 1 and 2 is recently used. 4 is the least recently used. That's why we replaced 4 with 6. 1 already in the memory, so no page fault. 4 not in the memory. 1 and 6 are used, so 4 is replaced with the 2. 2. So 2 is referred, so there is no memory. So choose the 4 and 1 are recently used. 4 and 1 are recently used. 6 is not recently used, so it will be replaced with the 2. 5 not in the memory, so 4, 2 and 4 are used. 1 is least recently used, so 5 will be replaced with the 1. 6 not in the memory, so 5 and 2 are recently used, so 6 is replaced with the 4. 2 already in the memory, so no page fault. 1 not in the memory, so replaced with 2 and 6 are recently used, so 5 is least recently used, so 1 is replaced with the 5. Next 6 already in the memory, no page fault. 3 not in the memory, so 6 and 1 are recently used. 2 is not recently used, so it goes out 163. Next 2 is referred, it is not in the memory, so it will replace with 6 and 3 is recently used, so it will replace with 1. So there are 12 page fault. Here you see that 2 is recently removed but it used in future, so that's why in LRU page replacement algorithm page fault may increase. In optimal we use